Hello guys, I hope you all are doing well. In yesterday's class, we have started with a new chapter that is polymer chemistry. So in today's class also we are going to continue with the same thing. Okay. So we started with the introduction part. है ना? Next we have seen with the degree of polymerization. Next classification, that is through head to head or tail to tail. And the second one, it is head to tail connection. Next, we have also seen the classification based on the configuration of asymmetric carbon atom, right? There were three types in that. One is isotectic, syndiotectic, and eutectic polymer, right? So next we have shifted with the type of average molecular mass. In that we have seen three types, that is number average molecular mass. Second one, it was weight average molecular mass or a mass average molecular mass. Third one we have seen with the Z average molecular mass. Right. So we have gone through the formulas also and the method of determination. Okay. And the method of determination is very important. They may ask a direct question based on that. Okay. So for number average molecular mass, we have seen the method of determination. It was osmometry method. Osmometry method. Okay. So here the method of determination, it was light scattering method. Yes or no? Light scattering method. Okay. Here it was sedimentation, right? Sedimentation, sedimentation, okay? Sedimentation equilibrium. In yesterday's class, I think I have just said sedimentation. No, guys, add the word equilibria there, okay? If you are new to the channel and if you are seeing this video first time, please go with the previous video of the introduction, then only you can understand this, okay? I will provide you the link in the description, okay? So guys, for this, there is one another representation for this formula. So we can see that representation here. Okay. So we can also represent this number average molecular mass as like this also. Okay. Just put M in a close bracket. Let me tell you the hint how to write this. Can you see the mass, that is Mi, molecular mass in a numerator? Just consider only the molecular mass leaving behind this number, okay? Number of monomer units. Here, try how you can write for weight average molecular mass representation. M is there, right? Not only M square is there. Just put it in a closed bracket. In denominator also, there is a M. Just put it in a bracket, okay? So this is another representation of a type of average molecular mass. Then can you just try it? Yeah, go ahead. So how we can represent this? M cube into the closed bracket divided by M square, right? So this is also a very important, guys, because instead of this, if they ask like this, then you should be able to answer the question. Okay. Yeah. Let's shift to the next topic. I told you guys there are four types and we have discussed only three types here, that is number, weight and Z. Okay. The fourth type is viscosity average molecular mass or a molar mass we will call, that is MVR. Okay. So let me give you the formula first. Later on we can discuss on this. Okay. So start copying down, guys. Make your own notes. So it is summation of NiMi. NiMi is common. Okay. Divided by NiMi. Here what we will write is Mi raised to 1 plus alpha. Okay. So whole raised to 1 by alpha. Okay. So this alpha is a constant. उसके बारे में हम आगे डिस्कस करेंगे. Okay. That is a constant. Keep it in mind now. Let's see with the method of determination here. Again, I am telling you guys, don't go in deep with the chapter. Okay, whatever I am telling, start noting that much. That much is enough for you. and OE बार बार revision करते रहो. Formulas, based on the formulas only you people will be getting an examination. Okay, so here method of determination, it is viscometry method. Okay, just remember viscosity, average molecular mass is the method of determination, it is viscometry. Okay, so for this we can go a little detail because there are chances to get the questions on that. Okay, so viscometry, by hearing the word we will, so first we can discuss with the viscosity on this. Okay, viscosity. So what is viscosity, guys? No need to go with the theoretical definition, blah blah, nothing. Just you should know with the concept, that much is enough. Okay, so viscosity, if people are already knowing about that, but let me tell you, let me consider a water, okay, or some solvent which is flowing like this. Okay, it is flowing like this. So but here I have kept a rod or something that decreases the speed of flow. Okay, as because of this presence of this rod, the flow, the rate of flow or a speed of flow of that solvent decreases. So that hindrance, okay, that hindrance or a resistance we can tell. Okay, hindrance or resistance to the flow of solvent, it is nothing but a viscosity. Okay, so let me consider an example, a simple example like honey and water. Okay, honey and water, if I ask you which flows faster, then definitely your answer will be water. It flows faster. Yes or no? Flows faster. So I can tell water has less viscous or honey is more viscous. Honey is more viscous than the water. Okay, so can I tell that more viscous, more viscous liquid flows slowly, है ना? More viscous liquid flows slowly, yes or no? So I'm telling this honey is more viscous. It might, because its rate of flow or a speed of flow is smaller or lesser than that of water. It might be due to the internal resistance, that is its mass, yes or no? Density of this honey is more compared to that of water. That might be the reason. So just this much is enough, guys. More viscous liquid flows slowly. Okay. Next. Now let me consider one more example. Like I'm going to take a solvent. Okay. Let me take a solvent like this. This is a solvent. You can consider it as water or some any other solvent. Okay. And in this solvent, I'm going to add a macromolecule. Okay. Huge molecule, that is none other than the polymer. Okay, let me represent like this. I'm going to add a macromolecule. Okay, so polymer. So guys, can I tell this whole as a solution? Yes or no? Yes, this is a solution where solvent, it is mixed with a solute. Okay, that is a polymer. So this solution is more viscous. Solution is more viscous than that of this solvent. Yes or no? Than that of this solvent. So based on this fact, based on this concept, there is a equation. Okay, where shall I write? Shall I erase this much? Yeah, let me go to the next page. Yes, let me write it here. Okay, so like what I did, I took a solvent, I added a solute in that, that is a macromolecule. Let me show here. Solvent is there, macromolecule is added. So this is a solution now. Solution ka viscosity or solution will be more viscous than that of the solvent. Yes or no? Because what we are adding actually, there we are adding high molecular mass compound, it is hindering or it is resisting the flow of solvent. Clear? Okay. Based on this factor or based on this concept, there is a equation that is eta is equals to, start noting down guys, okay? Eta is equals to eta naught 1 plus ta into, okay? Yes. So this is square bracket, okay? Yes. So this is viscosity of a solution, okay? Viscosity of a solution, this whole solution. This one, it is viscosity of a solvent, okay? Whichever solvent we have taken. So this C, definitely it will be a concentration, okay? So what is this one? This one, it is intrinsic viscosity, guys, okay? Intrinsic viscosity. Viscosity, okay? So if we calculate the value of this intrinsic viscosity, then we can easily calculate the value of this. What is this? Okay, what is this? This one, it is a viscosity average molecular mass. Okay, so now we need to calculate the value of this intrinsic viscosity. And just keep in mind, unit of intrinsic viscosity it is. So how we will solve the unit? It is like in intrinsic viscosity, it is 1 upon density. Okay, 1 upon density. Density ka unit, it is density mass by volume. So it will be gram by cm cube. Volume, how we will represent? By cm cube or liter, dm cube, ml, meter cube. Yes or no? So it will be cm cube, okay, per gram, right? Per gram cm cube, okay? So this is unit of intrinsic viscosity. Keep in mind. Clear? Yes. So next, let me write eta by eta naught is equals to 1 plus this, okay? So let me write like equals to eta naught minus 1, okay? So eta, okay, so intrinsic viscosity will be equal to viscosity of the solution divided by viscosity of the solvent minus 1 if and only if C tends to 0, okay? When C tends to 0, then I can tell that intrinsic viscosity will be equal to eta by eta naught minus 1. C never be equal to 0. Keep in mind, C never be equal to 0. This is not possible. The value of C, when the value of C will be very, very lesser, at that time intrinsic viscosity will be equal to eta by eta naught minus 1. That we can tell. Getting? Okay. So based on this equation, guys, there is a graph, okay? Definitely the graph will be provided in a question also. They need to provide, then only based on that graph we can calculate the value of this intrinsic viscosity, okay? So such questions have already appeared in PYQs, that is previous year, okay? So at that time only we can discuss about this equation, okay? Keep in mind. So now no need to discuss about the graph. There only we can discuss, this much is enough now. Getting? Yeah. So now the thing is, what if the graph is not given? Then I said, if and only if the graph is given, then we can calculate the intrinsic viscosity value. What if the graph is not given then? Yes or no? At that time, there comes one more equation, guys. Okay, that time there comes one more equation, that is Markov-Howing equation. Okay, so what is this Markov-Howing equation now? A very important equation, just put a star mark there. Okay. So what is that? Eta, that is intrinsic viscosity, will be equal to K into, what is this, mv then? Yes. What is that? Viscosity average molecular mass raised to alpha. Okay. So now just put it in one square box or round off it. Okay. So this K and alpha are constant, guys. Okay. K and alpha are constant. Just make a perfect notes, keep revising it again and again. Okay. K and alpha are constant and the value depends on, okay, value depends on, don't neglect a single line what I am writing, because in every line there is a p by q on that. Okay. Value depends on a solvent, value depends on solvent and size of the macromolecule, size of macromolecule. What is macromolecule? It is a polymer. Okay. So this sentence is also important. Okay. Value depends, that is K and alpha ka value depends on the solvent as well as this. Sorry, huh? This one, it is star mark actually. Okay. Important. Okay. Depends upon the size and the solvent and the size of the molecule. Can I write it as it depend, that is, it is nothing but it depends upon, depends on solvent polymer pair, right? Solvent polymer pair. Okay. Solvent polymer pair. There was a direct question which was asked, like they have given the equation, they have asked K and alpha depends on, there were four options and they have asked, they have given this option, that is solvent polymer pair. Okay. Keep in mind. Acha. So yeah, one more thing, alpha also depends on, alpha, that is value of alpha also depends on geometry or shape of the macromolecule, or shape of macromolecule. Molecule. Done. Okay, this much is enough. Okay. So let's draw a graph for this, guys. If you people have studied with the chemical kinetics, then you can easily draw a graph. Okay. So the same equation take down, that is intrinsic viscosity is equals to K into V alpha. Okay. So put log on both sides. One more class is remaining. If we complete that class now, then we can, let's start with the solving of questions. Okay. Alpha log. Okay. Gotcha. So how I did this? Taking log on both sides. This is log AB. Log A into B is nothing but log A plus log B. So log A plus this alpha comes down. It will be log MB. Clear? Gotcha. So on this equation, so okay, so it is quite similar to y is equals to mx plus c ka graph. That is a straight line graph. Okay, so let's draw a graph. So it is y, that is log n eta, sorry, eta, okay, versus log of mv. Okay, right. So it is a straight line graph where log k is a intercept. Okay, and slope it is alpha. M is equals to alpha. Slope it is alpha. Okay, so this graph is important. Okay, so just like just consider the equation was like is equals to log k minus alpha log mb. What if the equation was like this? Then how the graph might be? Yes, how the graph will be, right? The graph will be like this, where here log n will be there, log eta will be there, log v will be there here. This one intercept will be log k. Okay, so the reason for this is this negative value, guys. Okay, this negative value. If the value is like, sorry, if there is a negative sign, then the slope, then the graph will be like this. Okay, if there is a negative slope, okay, minus alpha, okay, minus m, then the graph will be like this. If there is a positive slope, then the graph will be like this always. Okay, just keep in mind. Yeah. So let's move to the next topic, that is polydispersity index. Okay. So in many textbooks, if we see, then the polydispersity index, it is represented by like this. Okay. D stroke we will call. Okay. Polydispersity index. Let's jump on directly to the formula, the important formula again. How we will represent it is divided by n. It is this weight average molecular mass divided by number average molecular mass. Okay, so can I again represent it as, how we will represent weight average molecular mass? It was like square, okay, whole divided by m. Yes or no? Am I correct? Yes, whole divided by, like this. Okay, so m square m into m. Yes, so how it will be? Into whole square. Okay, whole square. So there is a difference, guys. This m square into close bracket, that is different, and this average whole square. Okay, so this much, this is what the polydispersity index. Okay, so this is what the polydispersity index. Okay, for a perfect monodispersive index, for a perfect monodispersive system, this polydispersity index will be equal to 1. Okay, keep in mind, for a perfect mono, okay, mono 1. Okay, so at that time, we know D is equals to this one. So at that time, we will be like 1 is equals to like this. Okay, so can I write it as MW is equals to MN? Okay, so this is what the equation. Okay, so they may ask, like, they may give you some values, so you need to calculate MW and MN, and they may ask you which dispersive system it is, whether it is mono, whether it is poly, whether it is bi, and so on. Okay, if we get the value of MW by MN, that is 1, then it will be mono. If we get 2, then it will be bi, like for a bi dispersive index. Okay, for bi dispersive index, by dispersive system, sorry, for by dispersive system is equals to 2. So at that time, what happens? 2 is equals to MW by MN. Okay. Can I write it as MW into 2 into MN? Okay. So like this. For tri-dispersive index, it will be D is equals to 3, like this. Okay. So by giving the values, they will ask which dispersive system it is. At that time, we need to calculate this MW, MN, divide it. If we get the value 2, that is D is equals to 2. If we get this value, which is equals to 2, then it is biodispersive system. If we get the value 1, then it will be mono. If we get 3, then it will be tri, and so on. Clear? Yeah. So this much is enough, guys, in today's class. So in next class, we will discuss with some more topic, and that will be the last class. बाद में हम discuss करेंगे questions. ठीक है? अच्छा. Bye guys. Take care. Happy learning.